In today's lesson, 7.1, we're going to be talking about radicals and how to evaluate them. A radical is basically a square root sign, okay? Except for sometimes instead of square root, we see it as a cube root, fourth root, fifth root, and so on. A couple of things that you'll need to know before we go ahead and start actually evaluating these. First of all, the number underneath the square root, so number 1, like we have 25, that is called the radicand. Okay, so anything underneath the square root is called the radicand. This right here, that is called the radical sign. So the square root is actually the radical sign. Now, what distinguishes things from square roots versus cube roots is what is right here in this kind of corner. You'll notice right now there's nothing in there. That's because there is an imaginary 2. So if it's blank, it's an imaginary 2, hence why it's square root, okay? Otherwise, usually it's denoted with an actual number. That way you can tell if it's a cube root or whatnot. Let's put that back up there. That is called the index. So the index tells you what you actually need, if it's a square root or cube root or whatnot. Let's go back for a second and talk about when we square something. So if we think about 5 squared, when we square that, we do 5 times 5, and that's 25. So whatever that exponent, that's how many times we use that number. Well, basically, the square root is going the opposite. Instead of squaring something, I'm looking for what number times itself will give me 25. So if I think about 25, it's 5 times 5. And looking at the index, 2, so I'm looking for the pair. So there's one pair, so what times itself gives 25 is 5. And let's go to the next couple examples. What times itself gives me 0? It's going to be 0. And what about 16 over 25? If we have fractions, all you're going to do is you're going to apply it to the numerator and then to the denominator, keeping things simple. And then you evaluate both. Square root of 16 is 4. Square root of 25 is 5. So square root of 16 over 25 is 4/5. Now, let's look at number 4. We have the square root of negative 36. Now, if I took just 36, or if I look at negative 36, and I think, okay, well, it could be negative 6. Well, negative 6 times negative 6 equals a positive 36, so that doesn't work. And we know positive times a positive is still positive 36. So you can actually not have the square root of negative 36. What we would write here is it's not a real number. So if you're wondering if it's not a real number, what is it? Well, we'll get to that later, but it's called imaginary. But we'll show how to write that a little bit later. So you cannot take the square root of a negative number. That's important to remember. All right, let's take a look at a variable right here. So if this was square root of 49 by itself, I think most of you guys could figure that out. It would be 7 times 7, so square root of 49 is 7. But what about the square root of 16? Well, remember what I said before, the index is 2. And like we talked about way up here in this example, we were looking for pairs. We had a pair of 5s. In that case, this would be a pair of 4s for the 16, pairs of 25, or pairs of 5 for the 25, and so on. So let's rewrite x to the 16 as actually 16 x's. Okay, so that's long enough. And what you're doing is you're actually looking at how many pairs there are. There's 1, 2, 3, 4, 5, 6, 7. There are 8 pairs. So since there's 8 pairs, that's what it is. There's x to the 8th. Now, do you have to write those out every single time? No. Let's think about this. If the index is 2, my exponent is 16, all you're going to do is divide the 16 by the index. And that will give you that 7 to the 8th. All right, number 6, negative 36. Now, I just wanted to throw this in there so that you kind of see the distinguish between 4 and 6. Notice in number 4, the negative sign is underneath the radical. In number 6, it's on the outside. So, you actually look at it as the square root of 36, which would be 6, then drop down the negative. So a negative outside the radical can work, inside the radical does not. Alright, you might want to pause the video and take out your calculators. Hopefully most of you know how to do the square root of a number in your calculator. If not, please make sure you come see me after class. It should just kind of be a square root button for most of you. But if you can't find it, make sure you let me know. So what I want you to do is I want you to put that in your calculator and just make sure that you do know how to use your calculator for an approximation. What I want to kind of quickly show you is that you can, although it's kind of tricky to actually figure out the actual decimal approximation, sometimes you can kind of get a decent range of it. So I want you to think of the number 3, okay? The number 3 is between 1 and 4. And the reason I pick 1 and 4 is because 1 and 4 are both perfect squares. 1 times 1, 2 times 2. So now I put the 3 in there. Now, let's say that I take the operation of taking the square root of all of those. Square root of 1 is 1. Square root of 4 is 2. Now, what you should have gotten in your calculator is approximately 1.73 ... It continues. Now, although that's not perfect, it does kind of give you an idea if you're kind of trying to figure out approximations of things, how far it would go. All right, let's take a look at cube roots real quick. Cube roots, very similar to square roots. You're looking for a number that 3 times itself, not 2 times like square roots, but 3 times will give you that number. So looking at the cube root of 0, what number 3 times itself would give you 0? Well, that would be 0. What about negative 8 now? Remember in a few examples above, we said we could not have a negative square root. But think about a cube root. If I take the cube root of 8, it would be 2, 2, 2. But since it's negative, I can actually have negative 2, 2, negative 2, and negative 2. Because 3 negatives does produce a negative. So if the index is odd, you may have a negative radicand. But if it's an even, then you can't have a negative. Alright, so we're going to look at the next couple. Again, with fractions, I apply to the numerator and the denominator. Oops, 64. So that's going to give you 1/4. And I want to re-emphasize number 10. Index is 3. And then we have x to the 9th. Remember, you're looking for now the triples. So I have 9 of these, so I'm looking for the triples because the index is 3. I have 1, 2, 3. And again, that's just a division of the 2. So it's going to give you x to the 3rd. Go ahead, pause the video, and I want you to do 11, 12, and 13 and see if you come up with the right answer. All right, number 11 is negative 4x squared. 12 is 2 and 13 is not a real number. And again, it's because our index is even, and we can't have a negative under an even index. Alright, the last thing we're going to talk about in this video is if you have we're going to take a look at this right here. This will be the last part of the video. If we have the index here, if it's an even positive integer, and it evenly divides into the exponent of the radicand, you are going to have the absolute of the radicand. Whereas if it's odd, then it is. Because if you take that, it can actually produce a positive or negative. Where if it's odd, it can only then be negative. So let's take a look at this. If my index is 2, remember we kind of talked about at the very beginning how these kind of are opposites of each other. So they basically cancel out, but because they're both even, it's actually going to be the absolute value of -5, which would be +5 then. Number 15, index is 2, so they're even. So 6 divided by 2 is x to the third. And again, because that index is even, it's absolute value. I want you to take a look at number 16. I know some of you are going to think, okay, I'm going to take the index, divide it into 2, and I'm going to get x to the first, and then maybe get a little confused when we get to there. Well, I want you to look at this right here. You should notice that that's a PST, and it can be factored. It can be factored to the square root of quantity x plus 3 squared. So index is 2. Again, they're even. So it's going to be the absolute value of the radicand, which would be x plus 3. Over here, 5 and 5, they cancel each other out, the exponent with the radicand. But because they're odd, that's actually, we don't need absolute value. That's going to be our answer.